Yay? Why yay?
Short.
We like short ones, okay. Using proportionality triangles, all right, what do I have here? Okay, so, we've got a bunch, just a few little theorems we're going to be looking at. So let's look at this guy here. A triangle with a segment in its interior, right? So what's an interior of a triangle? The inside. Here's a segment. Whoops, KN is a segment. It forms a similar triangle inside the triangle because of AA. Because what else do I have here? I know it's parallel. So why is this thing, JKN, similar to the big triangle, JLA? Why is that? Yeah. Okay, so which angles are you finding congruent? Okay, yeah, that's this one. And that's because corresponding angles, parallel lines are congruent. Oh, it's hard to write. Okay, are congruent. And then I've got another angle up here, angle J, because of why? Why? Reflexive property of congruence. This is a mess. So I've got angle, congruent. So I have two congruent triangles. You may recall that the mid-segment is a special case of this. Remember what the mid-segment was? It was the same thing, except it connected the midpoints. So that also is going to create the similar triangles just like this. But we have that special condition that the mid-segment itself would be half the length of the other side. Remember that one? But that's not always true. Because this is not a mid-segment, I can't assume that I have that same ratio of the length. So just be careful not to confuse the two. Parallel lines and segments will create similarity in other places because of their unique angle properties. Okay, so we have a theorem. A line is parallel to one side of a triangle if and only if, so that means biconditional, right? If and only if. It intersects the other two sides proportionally. Okay, so it's parallel to one side of a triangle if you get proportional sides. And if you have proportional sides, then the lines are going to be parallel. It works in both directions. So let's see here. TU parallel to QS says RT is to TQ as RU is to US. And if it's true that RT to TQ equals RU to US, then you may conclude that the lines are parallel. Here's just a simple example to just kind of illustrate it. So I want to find RQ. There's my X. I am given that I have parallel lines here. So that means that this theorem is now in effect. So I just say this piece, the X to the 9 equals the 4 to the 6. So I have that proportion. And I can go ahead and solve this. You could go as is. I've been kind of liking to reduce them first. Whoops. And it just makes it a little bit easier. So x over 9 is 4 to the 6, which is 2 to the 3rd, or 2/3. So do cross product, 3x equals 9 times 2, which is 18. So x equals 6. Yeah? Questions on that? So that's just understanding where the proportion is. This piece to that piece to that piece. Okay? Let's see what else we got. We have another theorem. That if 3 parallel lines intersect, 3. So here I've got 3 parallel lines, R, S, and T. If you have that, and they intersect 2 transversals, so L and M are my transversals, they divide the transversals proportionally, which means this little piece here between U and W, we can call that little x, and between W and Y, we can call that little y. That piece to that piece is proportional, so we'll call that piece A, to this one, to that one. So x over y equals A over B. And that's what this is saying here. I think it's a little hard to see it as UW to W to Y equals BX to XB. So just looking at an example, so I see 3 parallel lines. How do I know these lines are parallel? How come? Yeah, we had a theorem that said, if they're all perpendicular angles, then they're going to be parallel. You can also say, well, look at all the corresponding angles. You can look at it that way too. So I do have 3 parallel lines. So what's going to happen with these two transversals, I'm getting that proportion. So x is to 51 as 36 is to 54. This piece is to this piece as that piece is to that piece. Just out of fun, is this also true? So what am I doing here? I'm saying this to this is the same as that to that. Is that true? You know when you say yes, my next question is, why? Who said yes? I heard somebody. Somebody else shout out. Was that you? Yeah, why? Yeah. Remember we did that little exercise with proportions? You can actually switch these, right? Those are called the means. You can swap them. Because why not? I'm still getting 54 times x equals 36 times 51. 54 times x equals 36 times 51. So, you can set up this proportion as this to this equals that to that, or you can set it up as this to this equals that to that. And I pointed out, because some people remember it better one way than the other. So, it'll work either way. And then we got to figure that out. Oh, goodness. I want somebody else to calculate it. Well, what is 36 times 51? What is it? What does it have?
1,530.
Alright. And now divide that by 54?
34.
Yes. Yes. You're absolutely good. And it makes it easier. 3x equals 1 and 2. Yes, you can absolutely do that. But again, you can set up the proportions two different ways. There probably other different ways as well. They could be inverses of each other. You can do that too. Another theorem. If a segment is an angle bisector, remind me what an angle bisector is. What is it, Michelle? Two congruent angles, right? So here they are. So because these are two congruent angles, that's an angle bisector. It divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. All right, so let's see. Let's call this one A. Let's call this one A. I'm going to call this, what should I call this little piece? E. So this is saying that B is to A as B is to F. So what's going on here? This is to that as this piece is to that piece. Or this piece is to that piece as that piece is to that piece. That's what this is saying. So AD is to DB as CA is to CB. Let's look at a quick example here. All right, what's going on here? Is this an angle bisector? How do I know? Yeah, it's got my two congruent markers here. So this is an angle bisector in a triangle. So I have this is to this, 8 is to 24, as this little piece here is to x. Now how am I going to write that little piece here? They didn't give me a value. Sam, what am I going to do? Yeah. Right, isn't this, if I know the whole thing is 28, and I take away the x, I'm left with this little piece. So now I have a proportion set up based on that. Again, we have written this a little bit differently. Let's see, because I always do them the other way. Yeah, is this the same? What the same? What did I do? I switched means. So that says that this piece to this piece is the same as that piece to that piece. For some reason, this is the one I always remember. That must be how I learned it 100 years ago. At least 100. It seems like it. So, but they both work. Whichever one you remember. This to this is that to that, or this to this is that to that. They're both correct. So let's see what we got here. We'll go with this one. They're the same. 8x equals 24 times 28 minus x. And I think I want to reduce it to 8 first, just to make this slightly easier. So I'm going to divide both sides by x first, just because the numbers get smaller, and I do better with smaller numbers. So what am I getting here? X equals whatever 3 times 28 is. All right.
84.
84. And then minus 3x. Remember right? Yes. And so then I'm going to add 3x to both sides. And And then I'm gonna divide by 4, and I'll say 21. Alright?
Yeah.
And so what's this one? 7. So I can find the other side also. Yes? And guess what? That's it! That's it! So what's the back? What's this? Oh, what's the stuff on the back? Oh, that's your turn. Yeah?
On that one, so you divide it by 1 divided by 8.
Here, I divided by 8. Isn't that what I said? I'm sorry, I thought I said 8. Yeah, you divide both sides by 8 so that we can reduce it a little bit. You don't have to. You don't have to do it. But to me, it's easier if there's numbers are smaller. Yes? Remember, when you're dividing, we're dividing this unit, oops. So this doesn't divide two things. If you were adding, if this was 24 plus that unit, then you would do that. But because it's multiplying, just divide. Okay. So yeah, these guys are for you. So we've got some problems. Oh, they're good problems too. So work these. Because really you have everything you need. If you have a question, just raise the word. Alright, so if you did these right, the first one you said they were parallel because of cross products. Should have gotten 15, should have gotten 24, should have gotten 15. No more questions, I think. Here we go with the second one. Answers to the second one. Let's see what I did. Anybody need help with this? I'm coming around. So the land is divided into that. So what am I trying to find here? I'm trying to find this whole distance. So I made that x because that's what I want to find. They don't have to. If you made this x, that's okay. But what do you have to do at the end? You have to add them together. So if you found this little piece in here, if you add them together, do you get 4,400? If you do, then you did it right. But you just have to remember that what are they asking for? They're asking for that whole distance. So I set it up as 2,000 is to what? X minus 2,000. As 2,500 is to 3,000. And then do your magic. And some of you know this, I could just knock these right out, 2 of the zeros. Which right away makes it easier. You can divide each by 5 if you want, and make this be 5, 6. It just makes some of the calculation easier. You don't have to, but it just makes some calculation easier. So go ahead, try it again. You should get 4,400. Now let's see what's going on with those last couple ones. Okay, what did I do here? I said they were not parallel. How come? Because when I tried to set up these two proportions, it didn't work. I did cross products and they weren't equal. So I knew that they weren't parallel. And then what's going on here? 350 yards. So what am I trying to find? I'm trying to find this distance. So that's the x. This, they told me, is a bisector if I read the question. Right? So I can kind of see my triangle in here, sort of, like it does. So what do I know? This to that, x to 700, equals 200 to 400. Boy, that comes right out. And that's really x is to 700. Oops. As 1 is to 2. And this one becomes easy now. 2x equals 700. So what's x? 350. We're working it out. Yes? Questions? No, we look thrilled.